Weather is all around us. Even when we think it isn't around us, it actually is all around us, all of the time, wherever we are. It's not just rain, snow, sunshine, and wind. Weather is a complicated combination of heat, moisture, dryness, pressure, currents, and stuff that come together in extraordinary and surprising ways to form an integral part of the ecosystem of the planet. Without weather, we wouldn't have things like snowmen, rainbows, yeast, or being alive. And although weather is something that everybody takes for granted, it is one of the most important forces in nature. In this programme, I'm going to show you how brilliant weather is, how important it has been for us. It helped both form and destroy civilizations, inspire artists and philosophers, and push technological development throughout the centuries. That's how exciting weather can be. I will be dispelling some of the myths and misconceptions, and perhaps even learning a few things myself. Is there such a thing as bad weather? Where does weather come from, and what does it all really mean? So join me, James Ewart, as I ask, what is the weather like?
What is the weather like? It's a question that we all ask. As a British person, it's my go-to question for initiating small talk, but it's also a subject that has fascinated me for a long time and also led me to a career in meteorology. But I'm not just interested in the sciencey side of things, I'm also interested in the personal human connection that people have with weather, how it affects their moods, how it affects their experience of the world. But what is weather? Where does it come from? What does it want, and why is it here? How would you describe weather to someone who's never experienced it? Well, you wouldn't, because if you hadn't have experienced weather, then you wouldn't be alive today. But where does weather come from? We all know it lives in the sky because we can see it and we experience it, but most people don't realise that it actually comes from space. When you think about it, it makes perfect sense, because weather's default setting is cold, and space is very, very cold. It was back in the 16th century that the philosopher, priest and poet Hugo Leroux did something truly remarkable. He accurately measured the speed of weather. Now, what Leroux did was he created a scale model of the entire universe. Now, obviously this was no easy task, but luckily he came from a very, very wealthy family, so he had all the means to undertake such a mighty endeavour. Now, in today's money, to construct such a thing would cost upwards of at least 170 million euros to build such a project, and at the time it also required up to 400 of his own personal staff. Now, I'm going to do the same experiment today, but I'll be using a sponge, 2 balloons, a paper fan, a ruler and an ice cube. You see, weather travels at 9.17 million yards per annum, and over the centuries this has been known by many names. The Romans called it velocitorium tempesque, but we know this today as the speed of weather, and because of Leroux's work we measure this in the units Hugos. We can work this out by measuring the distance travelled by this controlled sample of weather now. You see, this has all the elements of the actual ecosystem of the planet. It has the wind provided by the fan, the temperature provided by the ice cube, and the landscape of the planet provided by the sponge and the 2 balloons. There. Do you see?
The brilliant thing about this is that it scales upwards indefinitely. It can be used not only to measure small weather changes, but also weather the world over. Leroux realised that when it became nighttime, the sun set because of gravity pulling it down. But how does it get to the other side? The key to this puzzle presented itself one night when Leroux was feeding his pet swans. He noticed that the weather is usually at its windiest after the sun goes down. He concluded that the wind will push the sun from one side of the earth to the other. The church, appalled by LaRue's claims, forced him out of the country. He lived the rest of his life in his new home in rural Switzerland, unaware of the true extent of his breakthrough. He died penniless and homeless 5 years later due to complications during death.
Since then, countless amounts of scientific breakthroughs have taken place. Back then, people didn't really understand weather. They didn't even know what clouds were made of or who started wind in the first place. Now, that kind of information is common knowledge. But what scientific advancements are happening now? What nugget of knowledge is on the cusp of changing how we feel and think about the weather? Such information can be found in scientific journals such as these. On first look, scientific journals can look very complicated, and they are. They're the cornerstone of scientific thinking and understanding. Scientists use these to put out their findings and information so other scientists can then scrutinise and interpret that data to make sure that it is scientifically sound. When flicking through this, you can see that the frequency of extreme weather is quite the hot potato in scientific thinking at the moment. But what is the deal with these rare and unexplained phenomenon? Why is this particular potato so hot? Is there any way of uncooking it? Would you want to eat an uncooked potato anyway? I'm here at the Sally Webster Memorial Institute for the Scientific Understanding of Science here in Hull to find out. I'm here with Dr. Keith Harcourt, who is...
Hello.
Yes, hello. Who is here to give us the lowdown on all the extreme weather that we've been experiencing recently. Is it all because of the global warming, or is it more complicated than that?
Hello, yes. Well, weather comes from space. As to clouds, but not originally, because water cycles, and yes, but the global warming, I was like here. Can I stand here?
Yeah, if you want.
Well, the global warming happens when warmness occurs, when the globe warms up. Now, throughout the lifespan of a planet, temperatures fluctuate from time to time, but only so much. What we've seen is a gradual warming, globally, that falls outside of this usual expected amount. So yeah, they are connected.
So, what's caused this?
Well, many things. Studies have shown that these may coincide with the global warmings. So, from burning fossil-based fuels, cattle populations, weather, volcanoes, the popularity of irons and kettles, all sorts.
I see, so the more of these things that have been happening, the more the globe has been warmed.
Yes, it's a measurable thing. And we have been tracking for some time now, and we can plot on graphs what we expect temperatures to do based on the trend.